We are going to look at real-world problems dealing with exponential functions. So anytime a value increases by a certain percent or decreases by a certain percent, it's going to be exponential growth or decay. Our function is this: f of x equals a, and then 1 plus or minus r to the t. So you're going to use plus if it is growth. But if it's decay, it's going to be minus. So this is two problems in one. It's saying use plus for growth, use minus for decay. You can't use them both at the same time. A represents the initial amount. Initial value. That's A. R is going to be the rate or percent. You'll write it as a decimal though. And the growth or decay factor is going to be what this is. It's going to be B. T, where we have it right there, that's going to be time in years. So we have two equations in one. We add one if it's an increase. We subtract from one if it's a decrease. So we are going to set up equations and then solve them for a certain amount. Okay, let's go to the example page. We're going to start out with exponential growth. So growth means we have an increase in the value. You might see the word appreciate. Like depreciate means decrease, but increase, appreciate, grow, those words you'll see for exponential growth. So depreciate and appreciate are opposites of each other. So appreciate means it's going to get bigger. And ascend means increase as well. So those are words that you may see. Ascends. So that's increasing. F of x equals a, 1 plus r to the t. So notice that with growth, it's going to be a plus. You're going to do 1 plus the rate. So example 1, the exponential function below models the amount of money in his savings account, Jose's savings account, where x represents the number of years since he invested money. What does 3,000 represent? This is like your A value. 3,000 represents his beginning balance or starting balance in his account. This says growth rate. Well, this is the B value. B and the growth rate are a little different. They are related to each other, but to find the actual rate or the percent of increase, we need to subtract from 1 because we need to find out 1 plus what gives us 1.06. So the way you find the rate, you would do 1 minus 1.06. And we only want the positive value. So it's like we're taking the absolute value. 0.06 is the rate of increase. We may want to write it as a percent. So we move our decimal over 2 places to the right to go from decimal to percent. Remember DP? 6% increase. Not bad, actually. A lot of times a savings account has like 0.01% increase, which is like barely anything. Example 2. Tuition of at a state college is $8,500 and is increasing by 3% each year. What is the cost of tuition after 6 years? So let's underline the important information. $8,500. That's how much it costs right now. So that's your A, starting cost. Increasing by 3%. So it's going to be plus the rate. The rate is 3%. So we've got to find out what that is as a decimal. R is 3%. So we need to move that decimal over. Percent to decimal means I'm going to move the decimal over 2 places to the left. If there's nothing there, we put a 0. We can go ahead and put that. So the equation that we're going to use is the A, 1 plus the rate, raised to the T. So A is 8,500. And then we do 1 plus 0.03 because it's an increase, raised to the T or X, whatever variable you want to use there. X or T is fine. This is the equation, but we do need to simplify it. So we need to go ahead and add this. So 8,500, 1.03 raised to the T. So this is the equation. This is the function for that situation. Starting at 8,500 and the tuition's increasing by 3% every year. So the cost of tuition after 6 years. So now we're predicting. So if you want to predict for 6 years, I'm going to put this here. Plug in six for T. So in my calculator, I'm going to plug that in. So 8,500, 1.03 raised to the 6. Make sure you know how to put this in the calculator. And it's dealing with money, so we are going to do to the nearest penny. So we need to write this in words. So after 6 years, tuition cost $10,149.44. So see how it increased? We have 8,500 and now it's 10,000. So that's a real situation. That really does happen. They can't stay the same amount. They've got to increase by a certain percentage. So they're increasing by 3%. All right, let's look at exponential decay now. So exponential decay, you're going to see the word decrease, depreciate, descend. Those are words that you may see. Notice that on this one, it's 1 minus the rate. So it's going to be below 1. Example 3 says an exponential function below models the value of Melissa's car, where x represents the number of years since she purchased the car. So f of x equals 28,000 times 0.86 raised to the x. What does 28,000 represent? Starting value, but in this situation, it would be how much she bought the car for. So purchase price so she bought the car for 28,000, and then it's decreasing by a certain value every year. So this is your A, this is your B. That's our growth or decay factor, so it's going down, it's a decay factor. Less than 1 makes it the decay. Rate of decay, so it's below 1, so you want to know how much it's below 1 to find the rate. So we do 1 minus 0.86.
24.
14. Then to write it as a percent, we move it over 2 places. It's a 14% decrease every year. And that truly does happen. You buy a brand new car, you drive it off the lot, and it starts depreciating right away. It's no longer a new car, so you can't sell it for that amount. The value is lower. Last example, student population at local high school is 1,375 and is decreasing at 2% each year. What will the student population be after 7 years? So we have 1,375 is our starting population. Decreasing means we're going to go down by our rate, 1 minus the rate. So our rate is 2%, but we've got to find it as a decimal. So I write 2, put the decimal there, but then I move it over 2 places. Yep. 0.02 is how much it's going down by. 0.02. Percent's gone after we move it. So we're going to do our beginning amount. Y equals our beginning amount, and then 1 minus the rate raised to the t. We need to simplify this part of it. 1 minus 0.02. Yeah, 0.98 raised to the t. So that is my equation. Then we have to predict. So it says, what will the student population be after 7 years? I'm going to do a little thing over here. So we're going to plug in 7 for t to find out what the population will be. So use your calculator. 1,375 parentheses 0.98 raised to the 7. With people, we can only do whole people because it's talking about population, student population. How many people are in the population? So we're going to keep this at 1,193. Don't round up to 94 because that's part of a person. We cannot round up part of a person, so we go down. So after 7 years, the population is 1,193.